world. So the thing is that we all know about climate change. We all know about how weather is drastically changing throughout the world, right? अब मौसम वैसे नहीं रहे जब से पहले हुआ करते थे किसी जमाने में, आज से 20-30 साल पहले. So now we see, like, we have seen the flood in Pakistan, and we are seeing a lot of other disasters, weather disasters throughout the world. And it's all because of weather change, climate change. Climate is changing. I mean, here, this part of the world is the most hot and humid in Middle East, which includes UAE, Qatar, Bahrain, Kuwait, and Saudi. Saudi is a very big country. It is mostly hot. Somewhere it is with hot and humid. Somewhere it is hot and extreme dry. But Kuwait, UAE, and Qatar, they are mostly too hot and humid. So the whole world is divided into weather zones. So there are zones which are like cold and humid. There are zones which are cold and dry. पाकिस्तान में भी आप देखेंगे कि जो सर्दी जो बहुत जोर की पड़ती है वो ड्राइनेस की वजह से पड़ती है. So if weather is cold and dry, it's even, more, it feels even more cold. So, so the weather is changing throughout the world. So just to give you an example, I mean, here it goes up to 55 degrees Celsius every year in almost like 2 months, two peak months like July and August, mostly June and July. But it's even increasing, like every 15 years, it's increasing by 3 to 4 degrees Celsius. It's increasing. And not just here, Kuwait, we have seen Pakistan. So last year, I was in Pakistan for like 2 months. I had a big vacation. And the summer, it was in summer when I was in Pakistan with my family and kids. And I have not seen this kind of summer all my life. And this kind of, because of the weather change, uh, there is a very big scope of HVAC. That's what I'm trying to say. Weather is changing drastically. So when I reached here back to Kuwait after my vacations, I came to know that here the temperature in the summer, it reached even 60 degrees Celsius. And not only that, because of 60 degrees Celsius, Kuwait electricity is almost free, almost free. So we use air conditioning in our homes, like for example, all 8 to 9 months of the year, except the 3 months. So for all 9 months, the complete bill that we have to pay for the electricity for the complete years is even less than 50,000 Pakistani rupees. That's how it's cheap here. But despite that how cheap is electricity here, despite that, uh, there was load shedding here. And that load shedding because of extensive use of air conditioners. There is abundant of electricity almost free, almost free. Like I told you, I have two ACs in my home, and they are always working. And the yearly bill that I have to pay in the Pakistani rupees is 50,000 rupees only for the complete year. But despite that, there was electricity shortage because of extensive use of air conditioners due to high load. And that due to high load is because of the temperature was reaching 60 degrees Celsius. In Pakistan, it was too hot and too humid. So I don't see why will not be a good scope of HVAC in the coming decades. That's what I'm just want to say, that the weather is changing globally and it's getting too unprecedented or unpredicted. We cannot even predict what's going to happen. Who had predicted that Pakistan will face such a terrible rains and flood? Just few years back, we have seen that calamity in Pakistan. So the HVAC systems, this is the introduction. HVAC systems have gone significant changes over the years. The presentation explores the future horizons of these systems, focuses on their global impact, technological advancements. So we have to first of all, understand where we are going with this weather change and all that. And then, like every other technology is evolving and there's innovation. We have innovation in HVAC also. So right now, we don't, we're just not having the smartphones or everything is getting smarter. So there is Internet of Things, there is 5G and all that. So, and all of that is used for the conservation of electricity, of course, and energy, of course. So for our sustainability. So these are the things that HVAC, I mean, in Pakistan, mostly when I go, the air conditioner means only the split unit, mostly. And this is sadly very, I don't know why it is like that. Maybe because electricity rates. But the thing is that HVAC is a very huge industries and there's innovation going on just like in any other field. Innovation is, but here, because of the weather, because of the energy, the innovation part is more serious and it happens with actual development because I mean, I'll give you example of here in Kuwait, but Dubai or UAE or now even Saudi, the electricity is very expensive as compared to Kuwait. It's not like Kuwait here. So when you have constraints like this, so there's a constant pressure or very serious effort to constantly do in new innovation so that we have more efficient system, something like that. So global market trends as global awareness of climate change increase, that VC market is shifting towards sustainable solutions. Emerging markets are expected to drive demand while established regions will focus on retrofitting and upgrade existing systems to new regulatory standards and customer expectations. So, sorry. So this is um, the overview that HVAC has the potential. Now the mechanical engineers or it's not necessary that they'll be going to the HVAC field because after graduation, mechanical has huge, you can get fit anywhere because the amount of stuff that you are taught with or you study, it can fit you anywhere. So this is, but since I belong to HVAC, so it's my job to give awareness to the current students or whoever the fresh graduates, that what is the scope worldwide, not just Pakistan, but worldwide for this field and what are, uh, so for the HVAC, if you have to if you, for example, make your mind in HVAC and you go want to uh, be an HVAC engineer, so I will try to give you those advices which I got from my seniors at that time. And that is to, first of all, you consider yourself a student and be a learner always. So for the HPC, first of all, you have to learn the psychrometrics. And the science of psychrometrics is very important. It's the heart of air conditioning or HVAC field. So, so the psychrometric, what is psychrometrics? It's the study of thermophysical properties of air and their interrelationships. So, which is basically the temperature and humidity. So what we deal in HVAC is like that we are not just cooling the air, but we also have to take care of the humidity because the comfortable is range of humans for being their comfort. It's not just a matter of temperature, it's the temperature plus the water vapor content or the humidity inside the air. Just before, like I mentioned, few places of Pakistan which are extreme cold because they are cold because of the low humidity in winter. So if it's dry and it's cold, it's killing cold. So because humidity, it kind of add the warmth, the feeling of warmth or heat. So if it is cold plus humid, it doesn't feel that cold. So just um, just a food for thought. Whenever you see a weather report, or you go anywhere in the world, or you just see the weather, or even in your mobile, there are gadgets of, they're displaying the weather information. But they tell something like that, that in Pakistan, I used to see, for example, in Lahore and Islamabad, it's saying the temperature is 46 degrees Celsius, but feels like 50 degrees Celsius. So they always say feels like, right? But it's not the just the temperature. So there are a lot of factors that gives you an overall feeling. So you'll always notice that with the temperature, the ride feels like. They'll say, sometimes they'll say that the temperature is 40 degrees Celsius, but feels like 35 degrees Celsius. So there are other things that play. There's humidity, there's wind speed, and things like that, that give you an overall effect. So psychometrics is the field that deals with all these kind of thermophysical properties. So psychometric is a study of relationship between the air properties, particularly in terms of temperature and moisture. Understanding these principles is crucial for enhancing HPC efficiency and performance. So psychometrics is a complete science. And uh, when I started doing psychometrics and I started studying, I felt there are so many software and tools you can find. Now there are even online tools that you can do any psychometric calculation. You don't even have to have the software or download it and install it. You can do all calculations online. But I wanted to make a software in Microsoft Excel. So I made that software myself in Excel long time back, that I made it in, I think, 2006. Yes, 2006. And then after that, I have shared my software throughout worldwide, and it has benefited many people, many companies. I never sold it because I cannot sell it, because the books, we being Pakistani, we don't buy the things, we don't buy the handbooks, we don't buy anything. And the formulas and all the things provided in that books, we have not bought, and we cannot earn because of those. So it's a matter of copyright. So I never sold that. So that's the thing, is that just a simple software inside Excel for the psychometrics, that was an idea. I said, no one has done this before. So I have done it, and I have been giving this for free ever since. And so psychometrics, we have all of these. So you can see on the left side that there's a psychometric chart, and on the right side, you can see all of these physical properties. There's dry bulb, there's wet bulb. So now I'm an HVAC engineer, and all my 23 years of life, mostly I have dealt with, obviously, HVAC engineers. And I'm telling you from my experience, like Kuwait, mechanical engineer, there are only two fields. Either he can go in oil field, or he'll be HVAC engineer, because it's too hot here. So we have like thousands and thousands of mechanical HVAC engineers here. And I'm telling you from my observation and my experience, that among those all HVAC engineers, 90% don't know what is even wet bulb temperature. And that's the truth. They cannot define it. They cannot describe you. They cannot. Simply, they cannot. They don't know what is wet bulb temperature. They don't know what's the difference between relative humidity and humidity ratio, right? So these things are very important for us to know. So don't take these things as granted, right? I mean, so everybody, now the thing is that all of these parameters, wet bulb, relative humidity, humidity ratio, and even the dew point temperature, they are actually a measure of humidity inside air. But each parameter is different. Each has a different application, significance, and use. But the people mostly, you make use of these terms as like any non-educated person will make use of. So it's very humid. How much humid? You will say 90%, 100%. So when we say these percentages, it is only relative humidity, right? So I'm just telling you, I'm not going to teach you what is dry bulb. Obviously, your teachers are there, and they for teaching they will be doing better job than me. But I'm just telling you that on the field, what happens? There are people, thousands of HVAC engineers, and they don't know even what is wet bulb temperature. So that's what I'm trying to say, because they don't want to study. They consider themselves engineers. I'm engineer. Oh, you engineer? Okay, answer what is what temperature? Simple as that. But they can't. The only reason, as far as I can think of, is because they think that they are engineers. Anyways, let's move forward. So after we understand these psychometric properties, we have to understand what are the different processes that are happening on the psychometric that we can consider or use psychometric chart for to describe those processes. You might have seen some kind of this kind of image or diagram before, that this is cooling, also called as sensible cooling, is heating, also called as sensible heating. And then anything that goes up, because on the, you can say this y-axis, we have the humidity, and on the x-axis, we have the dry bulb temperature. But it's not only x and y. All of these parameters, all of these parameters, they are all present on the psychrometric chart. So there are these kinds of lines. So on this, you can see this line represents the dew point temperature, and this vertical line, they represent the dry bulb temperature. And then uh, these sloped lines, they represent both enthalpy and the wet bulb, but their slope is slightly different, not exactly the same. And then we have the specific volume, we have the relative humidity lines that are curved lines, and all that. So all of these things, if you they are here, and this is cooling and dehumidification, when your air is getting cooled as well as dehumidified. And then you have heating and dehumidification, that your temperature goes high, but your humidity goes low. And that there is heating and humidifying where your temperature goes high as well as the humidity goes high. And then we have cooling and dehumidification. Okay, cooling and dehumidification, which is here, and then there is cooling and humidifying, which is this process. Now in Pakistan, where they make use of this water coolers, that process is evaporative cooling or adiabatic cooling, or this, we call it cooling and humidifying, because we are getting cooling at the expense of humidifying air, because there's no compressor in that. So when we have a compressor, like in air conditioner, we have cooling and dehumidification. These are these processes, just an overview for all of this. And so I think this, uh, yes. So this is very important to understand the psychrometrics. Without this, uh, no HVAC engineer can say that I know the design, I know the calculations. So this is the first step. And I remember I was doing for like almost 8 months the practice of these psychrometric processes, not using any software, but manual calculations with my hand for all kinds of psychrometric software. It in home or in office, but I was doing over and over again and again, just to get myself a physical sense of the things. So one of the things that I usually like to tell, if somebody comes to me and said, can you give us some um tip or some, what do you call that? Uh, some advice, not the advice, but um, I think you understand what I'm trying to say. A tip, a useful tip. This is what I tell them. I tell them, if you're an engineer in any field, in whatever field you're in, you might be electrical engineer, you might be electronics engineer, you might be mechanical engineer, you might be a petroleum engineer, or whatever. But here's the thing. There are physical parameters that you make use of in your professional work, or your daily official life. Like, for example, being an HVAC engineer, what are the parameters that I deal with? We deal with, first of all, let's say the tonnage, you know, 2 tons AC, 3 tons AC, 4 tons AC. Then there is a parameter, of course, like temperature, you know. Then there's a parameter like flow rate, the flow of air, could be flow of water. Then there is a parameter called static pressure or total pressure or dynamic pressure, static pressure of air or static pressure of water. And then there are lots of these parameters. If somebody is from electrical side, he may have like voltage or kilowatt or like amperes, something like that, or even ohms and the capacitance in farad or whatever. So this is what I tell them, that for every parameter that you make use of, try to get a physical sense of that physical parameter. Now, what do I mean by physical sense? So let's say the physical sense means that physically you should be able to sense it without using any instrument. So physical sense of, for example, what is a physical sense? Physical sense means it could be even for the speed. So let's say you're standing on the road and you saw a bus, and then you saw a very speedy car, and you can judge that, the bus is traveling maybe at 50 or 60 kilometers per hour, but the car, its minimum speed was like 100. It used to be 100, or it has to be 120. So you have a physical sense. You lift a weight, and you should be able to, you see that it should be like at least 50 kg. It should be like 40 kg or 20 kg. And you lift something and you should, oh no, it cannot be more than 10 kg. It's less than 10 kg. So this is what I mean by physical sense. It's a very, it's a lifetime useful skill that will benefit you throughout your life. Throughout your life. You go somewhere, you have to, do the survey of the job, and you see a big kind of ground, and you can sense that, this is about 800 meters or 400 meters by just physically seeing. You see a room, you go to a room, and by looking to the room, you can see that this room is just like 4 meters by 5 meters or 3 meters by 5 meters, something like that. And same goes for the temperature and the tonnage and the flow rate. You should have a physical sense of all of these parameters. You see, in our university, UET Lahore, there used to be a, person who was ironing the clothes for us. So we used to give him our clothes and he used to wash them and iron them. So he didn't have that sophisticated iron. Rather, it was kind of a desi iron that he used. He used to put the coals inside. So he doesn't have any switch kind of thing or any slide kind of thing so that he can adjust the temperature or whatsoever. So I saw him using this kind of skill. So what he used to do is that, for example, this is iron is in his hand. He used to bring the iron close to his face to sense the temperature. And then as per the cloth type, he used to use that, right? So he didn't have a sophisticated iron with sensors and, with a dial where you can adjust as per the cotton or nylon or polyester or whatever. But he had developed a sense of temperature, and he knew that how hot it should be for any particular type of clothes. And I was amazed that, without a sophisticated iron, he has learned this skill. So you know what I'm saying, right? So this is very important. You have to have the sense of every single physical parameter. All right. Without that, you are just dealing with the numbers. Just like you are in the university, you are given numerical problem where you will just put in the numbers to get the numbers. Okay. And your correct answer will depend upon if you get the numbers correct only. That's it. But in the engineering life, I cannot have something like 1 kilowatt if it has to be 2 kilowatt. I cannot have 1 ampere or 5 ampere if it is 1 ampere, because if you don't have the physical sense, then if you get the calculation and if you have the physical sense, you will come to know that you have done something wrong, right? Because you have a physical sense of that. You will not only consider those just as numbers. Rather, you will have physical sense. So it will help you in your calculations even. You'll say, oh, with that sense only you'll come to, oh, it cannot be this much weight. It cannot be this much force, for example. It cannot be this much pressure. I might have done something wrong. So this is just some came in between and just started, but this is a very useful skill. Every physical parameter try to have a physical sense without the use of any sensor or instrument. So let's say is we go to the cooling load calculations and the methods that are used throughout the world. So in the university, in the mechanical engineering, they do learn all the cooling load calculation and their methods. But the method that is taught in the universities, that is the basic method, but it's kind of obsolete and now nobody uses it. But this is basic and you have to start with that. And that is why it is taught with that. If somebody comes and asks that, oh, if it is wrong, it is obsolete, and it is completely outdated, but still it is taught. And yes, it has to be taught, and your basics of fundamentally you have to start from that method, which is this CLTT method. It's called cooling to temperature difference. Just like right now, atomic structure, it has the study of atomic structure, it has evolved. But when you start studying the atom and their structure, you have to start with Dalton's atomic model, then Rutherford's atomic model, and then you have to start from there. That's what I'm trying to say. And then you take your progressive knowledge as it has progressed in the field. So CLTD is the method that is taught in your course, in your universities, but that is completely outdated. It's completely obsolete. No one uses this in the world, except only those who do the manual calculation. But right now we have the tools, and tools is the main theme of this presentation, that what are the tools for. When I was AC technician, when I was a labor myself, uh, someone advised me that if you know the use of a tool only a tool, physical tool, you are half an engineer. So when I became engineer later on, and I just got this idea or thought that now these are the tools, that the software, they are the tools. We have like AutoCAD, we have other tools, some many engineering tools. So if we only know the use of that tool, that does make you half the engineer. So CLTD is the only method which is, completely manual. There is one software based on CLTD, but nobody uses it because it is outdated and it's completely obsolete. But you have to start calculating manually using the psychrometric knowledge also, and a lot of heat transfer equations and heat transfer things also. And then this is your start or basic to start with. But there are other methods also. The thing is that all of these methods, they have completely different physics behind. So let's say I'm sitting in a room and the wall next to me, it's an exterior wall, and then outside sun, and now how the heat will come to my room. There are 4 different physics methods that will explain how much heat will come inside and what is the actual process of getting that heat inside from a single wall, because it involves very complex heat transfer equations which involve the high differential calculus. So there's not a single way or single well-defined way that how does this happen? How does the heat goes inside? What we study in the university is cooling low temperature difference. Then there is this method, RTS method. It has completely different science and physics. And then there is transfer function method. Again, a different science and different physics. And then there is heat balance method. So all of these, their physics is completely different. The formulas to calculate the heat load is completely different. The physics is different. The methodology is different. How the heat is transferring inside, what parameters are used to calculate that heat, what factors are used to calculate that heat are completely different. So that's why it makes it more interesting. So some of the methods of these, all of these four methods, so the heat balance method is the most accurate method and most used method. And then there is RTS method, radiant time series, and then transfer function method. I have used TFM and RTS, and only of one or two time I have used heat balance method. So we go to CLTD. So the CLTD is just a very simple, a very basic that we study inside the university, just to get the idea that here is your wall, here is outer temperature, here is inner temperature. You get the delta T, and you get certain factors like U value or the overall heat transfer coefficient or whatever. And then you simply calculate the heat transfer. That's it. It's as simple as that. But other methods, they don't have this kind of physics. Their physics is different because actually the physics is different. Actually, the heat does not come to your room like that. There's simply outdoor temperature and indoor temperature and some thermophysical property of the wall, and you just plug in the equation, you get the answer. No, not it's not like that. For example, the most method that I have used is the transfer function method. The transfer function has a different technique. Uh, how it's what it considers that a certain amount of heat is getting subjected on the wall. It is mostly in terms of radiation and convection because there's mostly no conduction at least inside the environment. Yes, but once your wall is heated, then it will conduct inside, it will have radiation, and it will have also the convection. So what transfer function considers that uh, and what is not there in CLTD. In CLTD, it's just the delta T and the wall overall heat transfer coefficient of the conductivity, and that's it. Heat is getting transferred without anything. But in transfer function, it's like that. It's there's a little delay that the heat will be transferred later inside your room. How? Because first it will store certain amount of heat inside, and then it will become a source of heat and transfer the heat inside the room. So you see the difference? So the physics is completely changed. And when we go to the RTS method, even that is entirely yet again, the completely different physics. So in RTS, we have some kind of like radiation. So the amount of heat that is getting subjected on the wall, some of it will be radiated back. Some of it will be uh, radiated inside. So there is all of these physics change. So I have written there key principles. Radiant heat exchange. RTS considers the radiant heat exchange between the building surfaces and the surrounding environment. The time series analysis, RTS analysis, the building's thermal performance over time, taking into account the effects of solar radiation, outdoor temperature, and other environmental factors. RTS solves the heat balance equation for each time step, considering radiant and convective heat gains and losses. So what I forgot to mention here, the heat balance method, I told that it is the most accurate method, but it's most tedious and lengthy method because the kinds of calculation here are completely, you have to make use of higher calculus to solve heat balance method. The heat transfer mathematics or the physics it makes use of this higher order higher differential equations, higher order differential equations. So if you're interested in learning this science, which is for the heat transfer and heat and mass transfer and the calculus and or higher calculus involved, I would suggest you, but I would suggest you to subscribe to a YouTube channel. He's the one of the best mathematicians on YouTube in the world. His name is Grant Sanderson, and the name of his channel is Three Blue, One Brown. And this is not just about this. If you're an engineer and you consider yourself a student, you should be subscribing the most beneficial YouTube science, maths, and physics channels. So Three Blue, One Brown is the best mathematician on YouTube in the world. His name is Grant Sanderson, and the way he makes his presentation and the way he explains the mathematics using his animations, there's nobody like him. He is on the top. He is number one, without a doubt. And the whole world admits that. It's not just me saying, the whole world admits that. So he has made a kind of lot of series with beautiful animation showing the higher order differential calculus involved in this heat transfer, which I'm talking about the heat balance method. Now, other RTS method and transfer function methods, they are the simplified versions of heat balance method. They are simplified versions, but they are derived from the heat balance method, but they are quite simpler than this method. So, these are the calculation steps. So I'm not going to for in detail the calculation steps, but it is just to tell you that the science is so attractive. Its science is so that you don't have well-defined way or knowledge that how even a wall is transferring heat from outdoor to indoor. There is a book called there is a body of ASHRAE. ASHRAE stands for American Society of Heating, Refrigeration, and Air Conditioning. So they have their handbooks. They are coming for after 4 years. After 4 years, so we we have those, like there's ASHRAE fundamentals and there's systems and equipment and ASHRAE applications. So I'm always curious about the psychrometric properties and how we calculate, how we can do the calculations, like say if I have dry bulb and wet bulb, so how do we calculate enthalpy? Or if, for example, if we have dry bulb and enthalpy, how do we calculate wet bulb and relative humidity? So there's equations, and equations are determined by the scientists who are doing research continuously. And then they come up with the mathematics and the equations, that this is the equation that you will use to find out, let's say, a wet bulb temperature or the dew point temperature or whatever. So the thing is that it's been like more than 100 years now since that guy, his name was Carrier, who invented the psychrometrics basically. And he find out all the mathematical relationships of all the psychrometric properties. But ever since then, these equations have continuously been evolving all the time.
ये चूतिया बाइक किधर लेके गया?
Hello? All right, so I'll continue. I think that was somebody. So what I'm saying, that all of these equations, they are continuously evolving because the research is going on, and after every 4 years, the equations, they get changed, right? So it means that the equations are evolving, our understanding. So it gives me an insight that humans, their knowledge with all that mathematics and everything, we cannot have definitive equations to determine the psychrometric properties of humidity inside the air, because the equations, they keep on changing, right? And the same goes to the heat transfer through a wall. So we have 4 different methods. So one is obsolete. We have 3 different methods. So each will give you a different result. It gives you a different physics, complete different methodology, a completely different variables involved in their mathematics, in their calculations. So then there is this transfer function method. I mostly use transfer function method, and the reason is the software. And the coming slide, we'll come to know what's the use of the software inside these because every software they have to make use of certain method, right? So the software that I use mostly that makes use of transfer function method. But anyway, the transfer function method and the RTS method, they are the simplified versions or derived simplified versions of the heat balance method. Heat balance method is most accurate. There's only one software I have come across that makes use of heat balance method, which is the most accurate method. And beyond that, just the cooling load calculation, there is also an increasing demand of energy modeling. So energy modeling is just one step away from your cooling load calculations. So all of these things that we are discussing here, they are the cooling heating load calculation method. For example, we have a hospital building and we have to determine the total load of my cooling plant, but how much it has to be, whether it has to be 400 tons, 500 tons, 1,000 tons, 2,000 tons, 5,000 tons, or even beyond like 20,000 tons or 30,000 tons. When I say something like 10, 20,000 tons, 30,000 tons, it's district cooling, and district cooling is being adopted throughout the world, mostly in Middle East as well. So the district cooling is a one plant providing the cooling to the whole city, the whole district, yes, to the whole city. That's correct. So that's called district cooling. So we have massive, huge chiller plants. They are located in one place, and usually that plant is called as energy center, and it has huge chillers, huge cooling towers, and then these chillers they chill the water, and the water is run in that city or in that district or a block. You can consider like Barrier Town, which is we can consider one block of Barrier Town, or whatever other societies are there, like Wapta Town or any other, or let's say one sector of Islamabad, not the complete sector, like for example, I-10, I-10-4, I-10-1, or G-14 or G-13-3, something like that. So the district cooling is the cooling which is provided for the whole sector complete. So I have done a district cooling design in Qatar and two in Dubai. So the tonnage was like 28,000 tons, 35,000 tons, like that. And the calculation part for the whole district was like 1.5 years, 2 years. Used to do calculations only to calculate to do the calculation for the whole district. And the project they used to go like last like of course this that project is not for like 1 month or 6 months, minimum 1.5 year, 2 years, because you have to do the calculation for the whole district, not just one building. This one building, no matter how high is it, even if it is 20 floors, 30 floors, you can finish it in like 1 month, one maximum 2 months. But whole district, you need years. So what I'm saying that there are these applications, and once you have to do the calculation, you have to make use of software to make your work faster. And besides the tools, they they are if you do calculations manually, there's always a factor of human error or whatever. But those software they won't do. But of course, every method has their limitation. But you should be knowing the use of every software, what method it is based on, right? And what mathematics is used, what method is used. So mostly
Sir, I,
electrical
I have a question regarding the career hub. So the career hub is
is
based on which method of
transfer
calculations?
function method, transfer function
Okay.
method. And I also make use of HAB because of transfer function. Even though I have used RTS also, and when Revit came in 2009, uh, there was a debate in the whole world community, everywhere in the world, that people wanted to use Revit. And the thing is that because Revit is very easy. It's advanced. In HAP, you have to input spaces manually, and you have to make the spaces. You have to make the system, give the system's input, and give the weather data, and so much input manually, and then you do the calculation. But in Revit, you have the building. You just set the location. The sun is going. It knows the sun path. It knows if a building is this much tall, how it will cast the shadows and all that. So you just run the calculation, and then you have the walls there, you have the windows there. You don't need to put manually. All right. So you just run the calculation and it should give you the result. And I remember I used to be a part of so many uh, science forums and HPSC calculations forums at that time. And that was a debate on world level that mostly people were making use of transfer function worldwide, including me, because I was making use of HAP. I was since beginning, I learned HAP. I took the training of HAP, and then or not, I just don't rely on training. I taught myself by going into so much theoretical details that it will give you advantage of course, for sure. But I knew what is a transfer function. I just don't know HAP. So if somebody says he knows HAP, but he doesn't know what is transfer function, it means he does not know HAP. That's what I'm trying to say. So in 2010, when Revit came, there was a huge debate online that the Revit is not accurate. It's completely giving wrong results. And when I got Revit, when I started working on Revit, the very first thing that I wanted to know that what method they are using. And with a little search, Google search, I came to know it's RTS method. And when I realized it's RTS method, I said, oh, that's the basic reason that's the basic reason why people saying it's not accurate, because they are using a Revit as if it's based on the transfer function method. But it's not transfer function, it's RTS. The science and physics completely changed. So what I did at that time, I learned RTS method completely with details. I studied it. I noticed the differences of the input between RTS and transfer function. And then I did the calculation on Revit for a building that was built by the architects. I ran the calculation. I did the complete simulation. And then I had done it with HAP as well. And it was like 99.9% precise, right? Because it's not like that you get any software, you just start putting the data and then you expect to click and get the output. No, it's not like that. You have to know what method is that software is based on. So rt is completely different, right? There are certain factors involved in RTS which are not there, which are not even discussed inside Revit, right? So there is absorptivity, there is conductivity, and there is reflectivity. Nobody uses them in transfer function method. So every kind of heat energy that is being incident on a wall, it is getting radiated inside, it is getting even reflected because of the color of the because of the color of that building, right? So nobody does that in transfer function method, but it is there in RTS method. So I hope this gives a more clear understanding of these methods. So then let's go to this, like the brother, he asked the question. So there is elite. Elite is based on CLTD and RTS. And then there is HAP, the one who question, it's based on transfer function method. And then we have train, the actually of this, I just stopped it wrong. The name of company is Train, but the name of software is Trace. So it's called Train Trace. Like HAP is built by Carrier, Trace is built by Train. I just finished, I made this presentation only within like 45 minutes and making use of course, AI tools. I don't have shame to mention that because I just also want you to encourage to make use of tools. I was very, very busy, extremely busy, and this all presentation I just prepared in like less than 45 minutes. Some late last night and some today right after, just right before just his presentation. So, and then there's IESVE, which is doing not just the cooling load, but also it is doing the energy modeling. And what is energy modeling? I'll come to that later on. I could not mention this in my slides or in my presentation, but it is very important and its demand is also increasing. So IES, it makes use of heat balance method, and the Revit is based on RTS method. So now we go to energy modeling. So this is what I usually ask people who are either in HVC field or they are MEP, building engineers or whatever. So it's not like an interview. Yes, usually when I interview somebody, if he has, for example, experience in any of the building services engineering field, this is a question I ask everyone. So what I ask them, say that when you pay for electricity bill, what actual engineering parameter you pay for? I would really like to some people to unlock their or unmute their mics and give the answer if they know that. So what I ask them is that what parameter they pay for when they pay their monthly bill. What is the parameter that they pay for? For example, if I go and buy milk, I'm paying for the liters. If I go and buy, let's say, 2 kg apples, it's the kg, it's the weight that I'm paying for, right? So when I pay for my electricity, what parameter I pay for? Can someone answer?
Kilowatt hour.
That's the correct answer. So kilowatt, and the kilowatt hour is the unit of what parameter? Can somebody tell this? What's the kilowatt hour is the parameter
Electrical
or
energy.
is the unit? No, that's wrong. Yeah, no, that is correct. That is correct. We pay for energy. All right. We don't pay for the power. We pay for energy. The parameter is not power. Why I ask this question? Because there is cooling load and then there is energy modeling, right? So the result of cooling load, that parameter, whether it is in tonnage or it's BTUs, like what you say, 12,000 BTUs is usually referred as 1 ton. Or or the metric unit for that is kilowatt. That not the kilowatt of electrical, but the kilowatt of cooling load or heating load, because that is basically the parameter is power. Now, when we do cooling load calculation, our end result is the parameter is power. And the unit, if you are making use of metric units, it will be kilowatt. If you are making use of IP units or imperial units, which are also called British units, like the only few countries in the world, they are making use of British system or the IP system, including USA, Canada, Pakistan, India, even UK has been shifted to metric units completely. So when I'm working with UK clients, they are no more using feet, pounds, tons, or British thermal units or horsepower. No, they're making use of metric system, completely metric. The whole Europe is metric, Australia is metric, and Middle East is khichdi, mixed. Sometimes we use metric and sometimes we use the imperial system. And Pakistan, just like the road system, like the driving, Pakistan is completely on imperial system, not using at all any kind of this metric system. So Pakistan's engineers, they are also confused because of this problem in but Pakistan is confused. What I'm saying confused, it means that if you have to say the distance between Lahore and Islamabad, they will use of metric, they'll use of kilowatts, kilometers. Nobody says miles. And in USA, nobody understands kilometers. They understand miles. In USA, nobody understands what is 30 degrees Celsius. In Pakistan, everyone has a physical sense of how it feels to be like 40 degrees Celsius, 48 degrees Celsius, or minus 2 degrees Celsius. That's metric, right? In Pakistan, if I tell somebody is that it is, let's say, 92 degree Fahrenheit, then everybody will be thinking, oh, 92, what is that? They don't have the physical sense of Fahrenheit. So Pakistan is confused between metric. A lot of, if I construct my home in Pakistan, the all units used for the length, it's in feet. So the length used in construction is in feet, but the distances of the cities, it's not in feet or miles, it's in the kilometers. So there is a big confusion in Pakistan. I don't know which system to follow. Somewhere they adopt kilometers, some metric, somewhere they adopt imperial. That's completely confusing. Anyhow, the discussion went somewhere. What I was saying that when you do cooling load calculation, your end output is the parameter is the power. Now the power, it could be kilowatt, not the electrical kilowatt. I'm saying the cooling load power, which is in imperial, you call it tons, like the split units in Pakistan, either it could be 1.5 ton, 2 tons, 2.5 ton, 3 tons, and so on. So this ton, its unit in metric system is kilowatt. So don't confuse the kilowatt with the electrical kilowatt, but it's power. Whether it's electrical power or it is thermal power, it's power. Now, when we use energy modeling, our end result is not kilowatt. Our end result is kilowatt hour. How much actual energy I will use and how much actually money I would pay against that parameter, right? So essentially, when we do cooling load calculation, we do it for the peak time of the complete year. What is the maximum dry bulb and what's the maximum wet bulb or humidity of any particular locality of 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 that region, right? So we come up with the result which is in the power. But when we do energy modeling, which many software do, including HAP, including IESVE and Revit, it's just one step away from doing the cooling load calculation. So the cooling load calculation gives you the output of power, but energy modeling gives you the output of kilowatt hour, which is energy. And energy is simply power multiplied by time. So, excuse me. So you determine the power of your complete cooling load plant throughout the year and all the kilowatt. If you even for one day, if you accumulate all kilowatts of 24 hours, so you'll just get kilowatt hour. That's the total energy used in one day, and then in 1 month, and then in the whole year. So what I'm trying to say, the cooling load calculation, usually nobody does the energy modeling because of the fear that the engineers they have. Maybe that is something else, you know. It's the same thing. It's the damn same thing. There is no difference between cooling load calculation and the energy modeling in terms of the input required from your side. The same thing, it is the same thing. Even if you have to do cooling load calculation, you are not doing it. You are making use of software. And energy modeling, you are not doing it. The software is doing. But the result is different. But engineers, I have seen the mechanical engineers, they are skeptical. If you have a mechanical engineer and you are in building services, so you will understand, you will get to know a lot of other things related to civil, related to the structure, related to the architecture, right? You will have the knowledge of so many different kinds of bricks and their conductivity and their heat transfer and the types of glass and the types of plastering materials. I mean, what I'm saying include nearly every building material that is being used, you will get to know about that, right? So, uh, so there is no difference. The only thing is that energy modeling is a simulation that computer runs for the complete year. So the computer will take time. You will not take time. You will get give the same input, whether it's for cooling load calculation or whether it's for energy modeling. But energy modeling is not the calculation for just one time. It is a calculation for the whole year. So it may take up to 30 minutes, 40 minutes, 60 minutes. Not a problem. You are not doing, computer is doing it. Just let computer do it, right? So don't get afraid just because it takes a lot of time. It's the same thing, right? That's what I'm just so mechanical engineers, they have this misconception about energy modeling, and that's why they refrain themselves. Because they're not confident, then they say, "Oh, I don't know this." No, you know this. It's the same thing, but as Goulding load calculation. So that's it. I just wanted to just cover these few things before I go to my next section, which is about the BIM and what is this BIM, because we have just like only less time to cover for the CAD and BIM. And now, uh, when we design our systems like mechanical systems and HVAC systems, we have to make use of some tools for the drawings, our drawings. Now, CAD, we have been using, like for example, even right now, the world is having a complete big change and the shift from CAD to BIM. But before we discuss the shift of CAD to BIM, I would like to just brief you something about what was before even CAD, right? Before CAD, we used to draw all the drawings manually. And then something like in 1985, they came AutoCAD and people started using. But at that time, the PCs were very slow. The software, they were responding very slow. So it took some considerable time for even CAD to come. But even when AutoCAD came, there was a reluctancy from all the world to go from manual to AutoCAD. Just to give you an example, in 2004, after 2 years of my graduation, I was working here I just got hired in a company and I had a high-rise tower project to take care of HVAC systems for the installation. And I had to draw the complete systems with their ducting and piping and with their equipment. And in that company here in the Middle East, which is considered like even better than at least Pakistan, and in that company in 2004, there was not a single draftsman and there was not a single PC in the company. There's no PC, there's no AutoCAD, and there's a very old Indian guy, and he was a very lovely guy. He was very old, he was Hindu, and he was doing all the drawings manually on a big A0 side board. And I just got crazy. I got mad. What in the world is happening here in this company? Why do you think? And I just told my management and my boss, I cannot do like that. It's not possible. He says, no, he's a good draftsman. He can make the drawings manually very fast. I said, no, I can challenge you there on that. I took very firm step. I said, no, yes, simple villas. He has been working on simple villas. He can do a villa in 2 to 3 days. I understand. That's not a problem. But this is a high-rise building. It has so many systems. It does not have only ducting. It has piping. It has instrumentation. It has plumbing, firefighting. You don't have firefighting inside your villas, right? So no, you cannot do that. So it took me like a week to convince them they get a PC in the company, get AutoCAD, get a draftsman. But eventually they got convinced, and then they came to know, yes, I was right. If they would, that guy was respected because he was working on that company for more 45 plus years. So that kind of employee is considered a faithful. So it is respected. So I'm not disrespecting him. He is doing a good job. He's given his life, but that does not mean that, we should be doing manual drawings, So it's not just this. So when I experienced this, I came to know that throughout the world, there was a being kind of a shift that whenever some new technology comes, the world is always reluctant to adapt to that technology. They're not ready. So even it took the whole world 5 to 10 years to shift from manual drafting to AutoCAD. Would you believe that? It took the world 5 to 10 years. Nobody in the world. Just one day I'm working manual, the next day the same engineer, he's on AutoCAD and making use drawings in AutoCAD. It doesn't happen like that. These technologies, they take decades for people to adapt. And the only hindrance, or what you would say, a rakavat you can say in Urdu, are the engineers, if they don't adapt to the new technology. So, like we have seen the shift, I have seen two shifts in the world. I mean, because I'm born in 79, I graduated in 2002. All right. So AutoCAD was, the whole world was almost getting transitioned to AutoCAD in 95, 96, 97, right? But still people were using manual. And I saw 2004, a company, they were doing completely manual drawings. So even if you have to make the section, you have to make the perspective, the isometric, orthogonal views, every damn thing he was doing manual. And I was blown away. Oh, what the hell, what on world is going on here? So uh, the same kind of transition the world is seeing again, and the only problem are the engineers, right? The engineers don't take interest in drawing at all. And this is something that I always mention. I was in Pakistan. I went to a couple of companies in Pakistan for BIM, for giving a detailed presentation about BIM. And there's a big problem in not just Pakistan, actually all the third world countries, engineers, there's a big problem in their mindset. The same which I started my discussion from, or my presentation from, that once they are engineers, they think that drawing does not belong to them. No, drawing belongs to you. That is why you are taught 2 years extensive drawing. Yes, you have to start with the manual. Your geometry should be good. You have to, if you are given, let's say, two isometric, you should be able to make one orthographic view. If you're given orthography, you should be able to make isometric view, right? You should know all of the geometry involved. Because all world is being shifted to like this drawing, let's the draftsman make it. No, it's the engineer's job. It's not the draftsman job. Draftsman does not have necessary analytical geometry or the trigonometry or the algebra knowledge. They don't have that. They don't have those knowledge of even the theorems, the geometry theorems that we have studied even before engineering. And they are used, they can be applied, and they are very essential, right? So for everything that we draw, for every engineering drawing that we make, all of your knowledge of trigonometry or analytical geometry is used there, right? So the third world countries, engineers, they keep themselves away from the crime. That is one of the biggest problem that I have seen in the third world countries. So they don't learn either CAD or BIM. That's the problem. They don't learn, right? It's your job. There's no engine. You cannot call someone even engineer if he does not do drawings, because drawing is called the sight of engineer, the eyes of engineer. Engineer has what he has. Engineer has the drawing. He sees from the drawing, he analyzes from the drawing, and all he has is the drawings, right? And then if there's engineer, he says, no, I will not take. I will not. I will do the calculation. Drawing is not my. No, drawing is more important than even calculations, right? And you don't ever think or consider that if you do the drawing, it will make you a less of an engineer. So when I was engineer, I wanted to learn 2D drafting just like drafters do, because nobody has told me all of these things. I had a feeling of that being an engineer myself, I should be more knowledgeable about drafting than drafters. Otherwise, how would I mentor him? How would I guide him? How would I even, give him guidance if he needs some guidance or help or teaching or training? If I'm not into drafting, how will I help him? That's the point. So there was a Pakistani boy here in Kuwait. He was working under me. He was a draftsman, and he became the reason for me to take interest in drafting and doing the drawings. And what was special about him? He didn't have good knowledge, not about drafting, not about engineering. The only thing that, you know, the only thing why he became the reason for me to get into drafting was his immense speed on AutoCAD. His speed was terribly fast. He's still there, he's still working here. And I mean, I used to stand behind him and I could not focus on the screen. He's zooming in, zooming out, panning here, going there, copying line. He was like the speed now beyond human capability. His speed was beyond human capability. He's from Lahore, and he didn't know, does not have the good knowledge of geometry, neither drafting, nor any system that he was drawing. He only had the speed. Whatever he had to draw, you can give him a sketch, and he will draw this in insanely high speed. So when I used to see him, I said, it's very interesting field, because if he is not a good drafter, he does not understand good mechanical systems, he can get very good plus point only because of his speed. Well, nobody could match his speed. So I started taking interest in drafting only because of his speed. So I started doing drawings. When I started doing drawings, I came to know there's a more engineering that I can do on drawings than the drafters, and which drafters they don't even know about. They don't learn the subject. They just learn how to draw a line, how to run certain commands on AutoCAD, how to make an array, how to make a rectangular array or the polar array, how to copy things, how to move things. You know, these are the things that they learn, and then these simple few commands they use to draw the certain lines, and they don't necessarily know what they are drawing. They don't know what is, for example, gallons per minute. They are writing gallons per minute, but they don't know what is gallon per minute, right? They are writing it is tonnage, it is this much kilowatts, but they might not know what is that, right? So if the engineer is getting into drawing, they can. So being in the building and engineering services, the most extensive tool being used was the CAD. And the CAD, it focuses on creating 2D and 3D design and drawings. But what is BIM? So here's what I usually tell uh, that on the drawing. In AutoCAD, mostly the whatever you draw, you're drawing the lines or arcs or whatsoever. But the software AutoCAD by itself, it does not know what this line is for. It doesn't know that. It's me. If I draw a line, I know that this line represents a duct. This line represents a wall. This line represents my mechanical equipment. This line represents a beam. This line represents a window. This line represents a door. This line represents a ceiling, for example. But the software itself, it doesn't know. But when it comes to BIM, it's not like that. Anything inside BIM, what you draw the same thing. What you draw in AutoCAD, you draw the same thing in BIM. But in BIM, the software knows what it is. It not only knows it's a wall, or it's a duct, or it's a mechanical equipment, or it's an A-terminal device, or it's a pipe, or it's a pipe fitting, or even a pipe accessory, but it also knows all the parameters, physical parameters concerned with that particular object or that particular component of the building, right? So if there's a duct inside Revit knows that it's a duct. Revit does not know that's a line. In AutoCAD doesn't know. We are just drawing the lines. But AutoCAD does not know what is that. But in Revit, there are well-defined components of the buildings. That is why it's called building information modeling. So it understands the components of the building. Not only it understands the components of the building, but it also understands all the physical parameters concerned with that component. So this is usually whenever I go and I give the training of BIM or Revit here in the companies, then I usually give examples because examples are useful for understanding and making someone understand or to give the concept. So everything that we make use of, there are certain parameters that are involved with that particular thing. So I usually give the example of a power bank. Everybody makes use of power bank to charge their mobiles or whatsoever. So when let's say you have to go and buy a power bank. So I would also ask the participants of the meeting right now to come and tell me that what engineering parameters they should be considering while purchasing a power bank. So who will answer this? Anyone? Or what parameters are involved? What parameters you should be taking care of? The same goes for also for the batteries. If you have to buy batteries for your solar power, solar panels, same goes for battery because it's the same thing. That battery and the power bank, they are the same thing. Or even if you buy a new mobile, you have to consider what's the battery. So what are the parameters? So the first parameter is what's the capacity for that power bank. Usually comes in milliampere hours. That is also the energy actually, how much energy it is stored because it is multiplied with time, so milliampere hours. So this is the first thing. And then how much time it takes for the power bank to get charged. And then how much time this power bank will take to charge my device. Another parameter, right? And then what's the cable that comes with and how much current that cable can carry, like 1 ampere, 2 ampere, 3 amperes. So these are the physical parameters. So whenever you are learning BIM, the one thing yes you should know that if you have to make use of anything inside BIM, BIM knows that what engineering parameters are related to that particular building component. So you should also know, right? How could you use something which you don't know, but software knows? So if I have like my a ventilation grill or air conditioning grill, there are many parameters that are related to that particular component, which I must know, which is like, for example, its size, the flow rate, how much flow it's throwing, how much throw of the air at a particular flow rate is there, how much noise it is going to make, how much pressure drop it is going to produce, like even the total pressure, the static pressure. So all of these parameters I should know because your software, not in CAD. In CAD, it's just the line and the arcs or the sublines or whatever, right? This is one of the basic difference that I just wanted to highlight. So data is typically represented in graphical format, lines, arcs, and data is represented in a structured and semantic format, objects, properties, relationships. So limited data exchange and collaboration capabilities. So in BIM, you have the enables data exchange, collaboration across disciplines and stakeholders. So what this essentially means that can you can make a 3D model and that 3D model can be shared on with different people and they can view on their tabs, on their smartphones, they can go inside and they can check everything, but not like CAD. Okay. So CAD primarily is used for drafting and documentation, and the BIM goes beyond that. You can do analysis, simulation, just like I mentioned, my experience of doing calculations inside Revit, right? That I made use to, I learned RTS method and I did my cooling load calculation using RTS method inside Revit. And then the calculation with transfer function of HAP and Revit, they were like 99% same. Now there was just 1% difference, and that difference is coming due to the different methods being used, right? One is RTS and one is transfer function. And then there are these examples that you must also understand the difference between the technology and tool. It's very important. So people make use of these terms interchangeably, which is BIM and Revit. They are not the same thing. So don't mix or confuse the two things, right? So BIM is technology, just like CAD is technology. CAD stands for computer-aided design. BIM stands for building and information modeling, and these are the technologies. Now there are tools or there are software that are built on that technology, right? So AutoCAD is the name of tool which is built on CAD technology, but AutoCAD is not the only tool that is making use of CAD technology. Or all your modern CNC machines, they make use of certain CAD software. They are doing the computer numerically controlled cutting or fabrication or welding or drilling, all of these things, they are making use of some CAD software. Not AutoCAD is not there, but CAD technology is there also. If you're doing welding, or even if you're doing cutting, the bending of sheets, like sheet metal factories, they make use of so many machinery that they make use of this CAD's tools, the CAD technology. So their tools are based on CAD technology. So CAD is the technology and AutoCAD is not the technology, it's the tool. So likewise, BIM is the technology, and the name of technology is building information modeling. And Revit is the tool based on that technology. And Revit is not the only tool based on BIM. There are other BIM tools as well. There is Tekla, there is Graphisoft, there is Revit, right? So you must be clear about these two terms. So when I'm trying to explain people this, they don't understand what I'm saying. So then I have to again give some example. I have to think myself, how do I make them understand? And I tell them, okay, here is another example. So there is an operating system and then there are software. So like Windows in a operating system, Windows by itself is not a software. You install the software inside inside that whatever operating system. So there is Macintosh, like in Apple or MacBook. So their operating system is not Windows. They have different operating system. Operating system. We have a different operating system, and then we have the softwares, right? Just like now we have Android and iPhone, of course, right? So they have a different thing, but you can get the same app or you can get the same technology in both of them. So you must be very clear in differentiating the technology and the tool. So CAD and BIM, they are the technologies, and AutoCAD or Revit, they are the tools. But they are not the only tools. There are other tools built on that same technology as well. So we go to the next one. So BIM uh, is getting adopted throughout the world with the very massive demands. And just like I before mentioned that engineers, they don't take interest and they don't want to learn even AutoCAD, the same mentality they are keeping, or they are consistent with the same mentality in when it comes to BIM. And when it comes to BIM, the amount of suffering or disasters that happening throughout the world in the organizations and throughout the world. I'm not talking about a particular location. This is happening throughout the world. And the reason are the engineers that they are not, they think that this is just a drawing tool and drawing is not my job. And no, it's not. The BIM, especially BIM, it goes beyond the drawing, beyond the 3D and the things that you can do inside BIM is, you know, you cannot even imagine. So right now, for example, I tell people, not the people, I do a lot of freelancing, and all the time I have a lot of freelancing work. I have my YouTube channel and I post videos that what I do, how I do, not how I do my parametric modeling, but what I do with my parametric modeling. And people had come and asked me, no, how can you do that? And for one particular thing, for example, I told this thing, I had to make use of calculus. This cannot be drawn by simple algebra. You have to make use of calculus. And they are blown away that for 3D modeling or for drawing in 3D, you have to make use of calculus. I said, yes. And I posted a video. Then I had to hire a complete, very good professional 3D animator to make me a video about that, that why I'm saying I'm making use of limits and calculus in my 3D modeling, and for them to believe, you know. So I paid from my pocket to make a video. So just to give you an example, what skills are required, and those skills are going to take you to the level which you cannot even imagine, you know, because I have reached that level and I have been trying people to convince and to learn this thing, and you know, to take them to the places where they cannot imagine. So sometimes even I have a lot of freelancing work that I have to do. If I, for example, if I get at the same time, if I get a project from Australia and Canada, so one is the east, one is the west, and the timing is completely, you know, right now it's about almost night in Australia, but in Canada it's the last night, and in Australia it's either evening, so it's a very huge difference. So even if I get these two, so I got too much terrible headache and too much, you know, I don't get time to do that. So I I wish if I can get somebody who get intimidated with these, who get interested in these, and I train him, and then I leave him that okay, you can go and you do. I will not going to own you. I will just only going to train you. That's it. But you do it, you learn this, and once you learn, you will see how much demand is there throughout the world. So I have been the because the only single step that I took, that um I delved into the drafting. It gave me so much enough leverage till now that what I have done and achieved inside Revit and parametric modeling, that I have not seen anyone able to do that. And because of that, I have a very huge demand on Fiverr. And if you happen to see the gigs, my Fiverr gigs, they are on top, right? And the reviews that I got from all over the world, whether it's USA, Canada, I'm working with the huge companies. But the thing is that I see the difference in those countries and in the third world countries when it comes to the engineers and the use of drawings in their professional career, is that when I work with countries like USA, Canada, Europe, I work with senior engineers, work with managers, I work even with the company owners, and they are doing the drawings themselves. And here are Pakistani, Indians, and Egyptian, the third world countries engineers, they have this, I'm sorry to use this word, pathetic mindset that drawing, no, 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 drawing is not my job. Shame on this mindset, I would say. Shame on this mindset. And I've worked with the managers, I've worked with owners, they are working the drawings on Revit or CAD themselves. And whenever they cannot do certain things, they come to me, I do for them. They don't find anyone, they find me. But the thing is that this mindset is very pathetic. I'm again sorry to use this word, but because of this, the engineers, not the engineer, the fields get suffered. The progress, the innovation, they get suffered. The kind of innovation that I have done inside BIM, uh, people don't even know how do they use algebra. What is the application of algebra? So somebody just asked, he was just he was just sharing a meme, you know, he said A plus B whole square is A square plus B square plus 2AB. And it's been like 30 years ever since I studied in my school, and I don't know where this is applied in the life. And I told them at the same point, I said, there's not a single day I don't apply this and many other things in my daily life. And he was like shocked by my answer. I said, yes, I do this in parametric modeling. And not only that, nearly every law of sines, law of cosines, law of tangents, you know, the analytic geometry, the calculus, the limits, I do all of these. I've been using this from past 15 years, every single day of my life. I have to invent new things. So because of this, these skills are on very high demand. All right. So there's a 3D modeling, you should be learning 3D modeling. So 3D modeling, you think in 3D means is what? That you see any object around you and your mind start thinking that, oh, will it be made by revolve or extrusion or a sweep or a blend? What could be the 3D modeling process for us to achieve that particular object that you see around? So uh, if you teach somebody programming, for example, and he's making the program, so not, all the day he'll be thinking the program and he will be fixing the bugs in his mind. So when you teach somebody 3D modeling, all day he will be thinking that what is in my hand, let's say this is in my hand, I don't think it's being shown because of the. So if you see a cup, if you see a mic, if you see anything, you start thinking that how would I make this in 3D? And then there is, of course, programming. So the programming you can do, the sky is the limit. You can make your own programs and you can, because not every software makes everything possible for you. But the good thing inside BIM or Revit is that all of the BIM software, they make a door for you to create more software to make things which are seemingly impossible possible inside Revit or BIM. So there is a door of API, right? So using that API door, you can always create your own software. If you say, so there are two kinds of people in this world. There were those who engineer, oh, I checked the Revit, got the training, but this is not possible in Revit. No, it is possible because there is API. And API means you learn the programming and you make the program and make that thing possible inside Revit, right? So that is the thing. So, and then you have to make use of a lot of algebra, trigonometry, calculus inside that. And then there is parametric modeling. And the time is short, and I really wanted to cover in detail what is parametric modeling. And parametric modeling, the idea is so fascinating and so revolutionary thing that, it's fantastic. So what's parametric modeling? So for example, you have, let's say, a fan or a pump. A pump is better to give an example. So now a pump is to be drawn into 3D, right? So you have different sizes of the pumps. Just like you have like an air conditioner, a split unit or whatever the air conditioning equipment, it could be 1 ton, 1.5 ton, 2 tons. So the size grows, right? So if the 3D modeling, so you draw a pump or you draw an equipment or whatever for that particular size, like 1 ton, and then another model for 1.5 ton, and then another model for 2 tons, and so on. So if there are, for a particular series of pumps, there are, let's say, 15 models. So the 3D modeling is that you will have to 3D model all of those 15 different pumps, right? But parametric modeling is different thing. So parametric modeling is that you will model that pump. There are 15 models. You will try that only once, right? But all of the features of that 3D drawings, whether it's a lens, whether it's the angles, or whether the thickness or whatever, you will assign a parameter to that. And then your geometry, your 3D geometry will be driven by parameters. So if you need a new model, you just change the parameter value and that is your new model. You don't have to model that again, right? So this is just a very, in a nutshell, basic idea of how fascinating that parametric modeling is. So you just draw anything or you just draw anything in 3D, but only once. And then to create a new model, you just change the parameter value and the new model is ready. So this making of 3D models, not just by the constant, but it can be with the variables, and the variables can be calculated as a function of other variables. And you have to make use of, like, if you, so you have to calculate, for example, a simple trigonometry, that if your Perpendicular goes there, the hypotenuse should be this. If the angle theta is this, with that theta, it has to maintain this base, for example, or this hypotenuse. So you derive your geometry by algebraic or trigonometric relations or even calculus, and you keep on doing modeling. So it can be driven by constants, it can be driven by variables, and variables can be calculated by any kind of equation. So I hope I have tried to convey what parametric modeling is. Just is a brief introduction. So this is the parametric modeling, and there's nothing like it. I have not seen in the field of drawings, engineering drawings, whether 2D or 3D, I have not seen anything like that parametric modeling, because if it fascinates you, then it takes your interest to the next level, and then you keep doing things and things and things. And I got so much obsessed with the idea of parametric modeling and this the, how it is made. They make use of either constants or variables that we can calculate using equations to make our complete 3D thing, right? And that parametric, it fascinated me too much. I got so much obsessed that I took it to a different new level, and that is something that completely my brainchild, and that's something that I have seen no one doing in the world. And because of that, I have a very huge demand on Fiverr and other forums. And this is what I also show on my YouTube channel. If I get time, I will share my YouTube channel. So parametric model, I have taken to even the next level. So like I gave an example that you have, for instance, a pump. So there are 15 different pumps of that particular uh, product or equipment. So you don't have to do the 3D modeling of all those 15 pumps. You will do it just once, and every single parameter, whether it's dia, whether it's length, whether it's width, height, whatsoever thickness, the amount of fillet, the amount of radius, the radius of the fillet, whatever. You will just do it once, but every single aspect you will assign a parameter. And then you can change the value of that parameter either by constants or variables to drive a new component. So this is parametric modeling. So I took it to the next level. So because the idea came to me that if we can make 15 models by just modeling it once, then we can also make two different entire things just by doing once. So that's what I call it something else. So you have one completely different product and other is completely different product. So by making use of maths and a lot of algebra and a lot of programming, I have to model it only once if I have to make two entirely different things. So in the 3D modeling, it would be hard to understand it, but I can tell you using other example again. So you might have seen, for example, convertible furniture to save your space inside your living space, inside your bedroom. For example, there is a dining table and it should just fold it and it converts to, let's say, a cabinet, or a chair can convert it to, let's say, a ladder or ladder stairs, or a bed converts to the sofa, or a cabinet converts to a dining table. So this is what I do with my parametric modeling. So the parametric modeling, because the parametric modeling is kind of doing the thing. So I just realized I can take it to the next level, and I took it to the next level. And because of that, my models have demand. So people come to me even from different fields like architecture. I have to tell them, no, I only do mechanical stuff. I don't know much about architecture, but they insist me. No, 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 we want work from you. I'm not an architect. Why you want work from me? Go and find an architect. I don't know these things, but they said, no, we want things to be done from you, because The kind of reviews that you have on your Fiverr account, we have not seen any kind of reviews from all over the world, from New Zealand to Canada and USA, right? So I'm just telling you, all of this happened because I did not stay away from drawing, just like other engineers do. So Revit for HVAC plumbing and firefighting. So there is Dynamo. Dynamo, that technology came somewhere in 2015, and this is and yet another very fascinating technology because I learned Fortran language when I was in grade 7, and I studied the basic language when I was in school in grade 6, right? So, and then when I was in ninth, back in 1993 and in 1994, I did C language. And before coming to even UET, I was master of C++. But then I just thought that I will not do programming anymore. So whenever I had to make some software, I always try to keep a programmer with me, you know. I pay him, I get my job done, but I always need a programmer lifetime with me. Just like we need a doctor, we need a lawyer, for example, we need an electrician, we need a plumber, right? So everybody needs these people, right? So for me, a programmer, I need always a programmer with me. I learned programming at a very early age of my life, but then after I decided that I will not do programming for certain reasons. So, but the thing is that in 2015, there came a new technology, which is the graphical programming or visual programming. So in that, you don't even have to do the programming, but you do the programming. How fascinating is that? You don't have to write the code, you don't have to do the programming, but you do completely different thing, but it's actually a programming. So that is this graphical programming tool. What you have to do, if you have used, for example, Microsoft Excel, so there are some certain functions inside those function wizard, which is also called as f of x. And there are so many functions. They are categorized as mathematical, for example, statistical, logical, and all that. So likewise, in this tool, there are these functions which are also called as nodes, and you just draw the diagram, you connect the nodes, and that is your code, and that is your programming. So khalas, you don't need to do coding anymore. How fascinating is that? You do programming without writing the code. That is Dynamo. You install Revit, every Revit installation, it comes with built-in Dynamo software inside. If you don't want to do, if you're good in C# or Visual Basic, that is another plus point. I don't have that plus point, but I can pretty use, I've made many softwares in Dynamo. Also, I have made those scripts. In the Dynamo, we call them as scripts. The coding, whatever we do with that diagram, that is called script. So even on my YouTube channel, I have those complete script. I have given the tutorials and all that. If you want to do actual programming, then okay, you're more than welcome. If you are knowledge of C# or even Visual Basic, so you can reach to the levels where other people cannot do. So the parametric modeling we have already discussed. So particularly inside Revit, they are called families. So families throughout the world, they are in high demand. And if you want to do this parametric modeling or even Dynamo or Revit, first of all, start with your mindset that you are a student. Don't think you are someone. Don't think you are something. Never ever think that. It's my brotherly advice. I got the benefit of, because one single thing, one single idea, one single advice, if you put in your brain, if that advice is correct, and if you implement that in life, it will give you the worldly benefits here. You will see you're completely that mind, one single mind shift or one single idea can change your throughout the course of your life. So I always suggest this, being a brother or being a mentor or being an elder or experienced and knowledgeable person in my field, an expert in my field, don't shy yourself away from the drawing. I have seen all my life engineers not taking interest in the drawing, because most of the engineers, that is why I go back to the first basic question, that what made you come to the engineering field? Most people, they just Because in Pakistan, because of the conditions, the political condition, we are the bread earners, right? So we just have to be engineer because we have to get a job and we have to run the expenses of the home. Yes, sadly, that is also true. But the thing is that what I'm talking on the point of view for the innovation and the industry that lacks a big time knowledge and skills, and where you can elevate yourself and leverage your skill set to go beyond what other normal engineers are doing. You don't want to do this, you not do this, you will get a job, you will do some kind of routine work. And sometimes I even go to the level of asking engineers that what I have seen engineers who don't have the mindset of learning and keep on learning new and new things. So I asked them a question because you have to make people think at least. So I asked them that you go to a barber or you go to darzi, what is called as darzi in English, I don't know, a tailor, yes, tailor. So what these people do, they kind of learn something to do, and then their job is to repeat the same thing throughout their life. It could be even a kasai, because that is by itself is a skill that way to, blow that toka or whatever is that called. Way to struck that, it's a knowledge and it's a skill, not everybody can make the big, into pieces, the meat pieces. So they learn these things initially and then they repeat their lives. So engineers, when they come to the field, they say, oh, I just want to learn how to do this. I just want to get this formula. I want to learn this formula. And then I want to use that formula throughout my life. No, that is, if you are engineering with this mindset, then there's no difference, sorry to say, between you and a Kasai, between you and a tailor, between you and a saloon barber. You know the difference. He is also learning one thing, and his intention is to use that thing throughout his life. If you are engineer, if you say, okay, it doesn't matter, 10 formulas, 50 formulas, 100 formulas, but only those, you restrict yourself to use of only those 100 formulas and nothing else, then there's no difference between you and that Kasai. Sorry to say. I am blunt here. Come and argue with me if somebody wants to. You should be a student. You should be learning throughout your life. And so here's the thing. I also tell by giving this example. So right now, for example, I have this Samsung phone in my hand. So that's whatever the model, 2023 model. So the first smartphone that came, or even smartphone before smartphone, there was the door of Nokia. Now, when I make a software, when I make a parametric model, I just try to find mistakes in my model, even if it has been accepted and people, throughout they they praise me for that and they appreciate my use of lots of maths and programming in my parametric modeling. But I keep on thinking and improving that, right? I try to find mistakes in my own work, just want to improve. Because if this mentality is not there, should be holding Nokia mobiles in our phone. So right now, let's say Samsung S25 Ultra has launched. Now, this is the best phone in the market. iPhone 16 is the best phone in the market. Now, is it best with them who are producing them? No, they'll keep on making better, right? I have, one question again. We are not using even the same WhatsApp, what we were using this WhatsApp. That was also the WhatsApp, but the updates are coming, the new features are coming. They keep on thinking, right? Just yesterday, I was listening to the audio sent to me by someone on WhatsApp, and I just noticed that they have introduced the speed of playing that audio right on there. I can that feature was not there when we initially had WhatsApp, right? Facebook keeps on changing. Every single app that we have on our Android or on our iPhone, we have the updates. We have the updates of our software. We have the updates of everything going on. So if you're an engineer, if you draw something, if you develop something, a program, haven't think that this is it. No, right? So here we end this, and now if there's if people have some question and answers, so we'll be having more interactive sessions. So my discussion is over. So if somebody has some answers, I'm ready to uh, answer them as per the schedule given to me by Mr. Faisal. And I have some people to some questions.
Sir, what are the technicals of BIM we have discussed in? Like, I can't understand what we have done in this whole session.
So the BIM is I just wanted to give a little bit introduction that what is the difference, because most people they don't try to whenever the BIM is explained to them, their mind is just simply shifted to, you know, Revit, oh sorry, AutoCAD. So if I tell them that this is, whenever I'm teaching Revit in the companies here, I got the same trouble which you are getting trouble with the people. So because they are thinking about, I'm teaching them Revit, that this is how we do things in Revit, but he is listening to me, but he's not understanding me, because his mind is at the same time also comparing the same thing with AutoCAD. So I experienced that. I gave like 2 weeks or 1 month training, and after 1 month I got response from that company that they didn't learn anything. And it got me thinking that maybe I'm doing something wrong, maybe they are doing something, what's happening here? So I came to know that whenever I telling them something about BIM, their mind was still thinking about the previous technology. So it's like if somebody is teaching somebody AutoCAD, that this is the command in AutoCAD, but he is still thinking, this is how I used to do manually. So in BIM, I tried to explain that this is a technology in which it understands the components of the building with its engineering parameters. And that is the introduction which you need to know at this point. So this training or this seminar or webinar, it's not about training of Revit or anything. I just want to give the idea that what is BIM, right? So the BIM, if you go to AutoCAD, AutoCAD does not know what is a wall, what is a ceiling, what is a pump, what is a window, what is a duct, what is a grill, what is air conditioner. It doesn't know that. But BIM knows that. He understands, this technology understands every single component of the building. So I hope I have conveyed this, because yes, Moise. So there was the hand raise has to be, what to do with hand raise.
Can you
You
tell
can go
me
ahead.
this app or application is available on Chrome or Play Store or Chrome or App
Oh,
Store? Available?
which application?
Uh, BIM application.
No, BIM application is not on the on your Play Store. It has to be installed in Windows. We do not have the Android. It's not a mobile app. It's a tool application to be installed on PC or your laptop. So there are iOS and there are Windows installed. You can get the Revit very easily, just like you can get AutoCAD easily. You have the cracks available. You can go, there are website, for example, getintopc.com. You can get any Autodesk software, not only Revit, you can get Inventor, you can get SolidWorks, you can get so many other tools. You just install them, you crack them, and just start using them. It's
Okay, sir.
not on the mobile, it's on the PC.
Okay, got it, sir. Got it.
Okay. Anyone else?
Sir, this building management system, BMS system, is based on BIM.
No, building management system is something else. That is, I think you're getting confused because of building in both. So BMS is the making use of your lot of actuators and controls using sensors to control a lot of electrical and mechanical and heat and HVAC systems in your building. That is a centralized, computerized electronic system, usually done by the computer to control your every actuator, to get your sensors also. You can do many things. You can switch on all lights on and off, the air conditioning on and off based on certain parameters. That has nothing to do with BIM or building information modeling. That is building automation system, also known as BAS, sometimes BAS or BMS, building management system, right? So it has to do with the controls of your electrical, lighting, mechanical systems through the computer with the softwares, r- communicating with actual actuators and sensors. It has nothing to do with them. So
Okay,
that's
thank you.
completely different thing. Anyone else?
So, sir, we have to some brought some sensor or transducer to connect with the software.
Yeah, the software, the all of these sensor manufacturers and the actuators, they usually, when they sell you these things, they have their own software which you have to use because uh, if you have to, for example, if you have to bring air conditioner to your home, there are the brands that you will go for, right? So there is like Gree, there is like I don't know the brands used in Pakistan. You know the brands, I know the brands here. So, for example, there is ABC, there is XYZ brands. So likewise, when you have to make your building full on automation, which is like building automation system, you will go to certain of these brands. Like Honeywell is a brand, and Johnson's Controls is a brand. So you'll go to them. So when you will get the actuators and sensors from them, of course, they will give you even their they will give you a laptop with their loaded software. That software communicates with all of these sensors and actuators, because you'll not do it yourself. You have to rely on these you have to rely on these vendors, just like you have to rely on the vendor. You have to either go to Gree or uh, what brands are there in for AC in Pakistan. There are some brands like you got what I'm saying, right?
Yes, we got it.
Anyone else?
सर हमारे पास थोड़ा सा टाइम है तो थोड़ी सी इस चीज़ पे डिस्कशन हो सकती है कि क्योंकि कुछ फैकल्टी मेंबर्स भी हमारे साथ हैं इसमें और कुछ यूनिवर्सिटीज़ में एज अ ग्रुप वो उन्होंने हमें ज्वाइन किया हुआ है, किस तरह इसको हम एज अ FYP या रिसर्च में यूज़ कर सकते हैं, इसकी इम्पोर्टेंस।
इसमें ये है कि जैसे 2016 का एक ग्रुप था, 2016 का एक सेशन था। सो मुझे कुछ खास एक डेवलपमेंट करनी थी इन रेविट एंड CFD। सो CFD तो वी डिड नॉट डिस्कस, बट आई थिंक अगर यहाँ पे कोई मैकेनिकल इवन लास्ट लास्ट ईयर लास्ट सेमेस्टर का भी है तो दे माइट नो, फैकल्टी मेंबर्स माइट नो व्हाट इज CFD। सो रेविट के अंदर और खासतौर पे HVAC की डक्टिंग के से रिलेटेड एक हमारी इंडस्ट्री प्रॉब्लम थी। तो वेस्ट में ऐसा ही होता है कि आपकी इंडस्ट्री प्रॉब्लम्स जो हैं वो जो इंजीनियर्स हैं जो जिनके पास टाइम नहीं होता, कि बिकॉज दे हैव देयर जॉब, दे डोंट हैव टाइम, तो व्हाट दे डू, वो यूनिवर्सिटी के स्टूडेंट्स के पास जाते हैं क्योंकि यूनिवर्सिटी के स्टूडेंट्स के पास वेला टाइम होता है। वी आर वेरी बिजी पीपल, ठीक है ना। तो वो उनके सिर्फ उन्होंने तैयारी करके तो पेपर पास करना होता है या जो भी है, लेकिन उनके पास एक फाइनल प्रोजेक्ट हो। तो वेस्ट में ये तरीका है कि जो भी चीज़ें हैं, इंडस्ट्री की प्रॉब्लम्स हैं, वो यूनिवर्सिटी में लेके आते हैं। तो इससे बोथ पार्टीज की विन विन सिचुएशन है। इंडस्ट्री की प्रॉब्लम सॉल्व हो जाती है, फाइनल ईयर स्टूडेंट्स का एक्चुअल फाइनल ईयर प्रोजेक्ट भी हाथ हो जाता है, ठीक है। और उनको while in the university, while getting studies, उनको actual industry की insight मिल जाती है और actual real problem पे वो काम कर लेते हैं। So like at the time I was in my final year, my final year project and many final year projects, they are just कोई यहाँ से पकड़ा, कोई यहाँ से पकड़ा, कोई अपने दिल से इंजीनियर तो बन नहीं रहा। तो कोई तो दे डोंट नो व्हाट्स गोइंग ऑन इन इंडस्ट्री फॉर श्योर, क्योंकि मैं भी उसी प्रोसेस से गुजरा हूँ। वी डोंट नो व्हाट्स गोइंग ऑन इन इंडस्ट्री, तो हमें इंडस्ट्री में जाकर ही पता चलता है कि इंडस्ट्री में क्या हो रहा है। ठीक है, जब तक हम यूनिवर्सिटी में होते हैं हमारा सिर्फ गोल यही होता है कि किसी तरीके से नंबर आ जाएं, पास हो जाएं, नंबर अच्छे आ जाएं, बस दैट्स इट। वी डोंट नो कि कोई दुनिया में प्रोग्रेस क्या हो रही है, बिकॉज हम किसी और माइंडसेट से यूनिवर्सिटी में आते हैं। तो मैंने ये इसकी पाकिस्तान में बहुत कोशिश की कि वो फिर फाइनली मैं कामयाब हो भी गया, मुझे एक सेशन मिल गया। उनको मैंने पूरा काम सिखाया, उनको रेविट सिखाया, उनको सीएफडी सिखाई, उनको इन्वेंटर भी सिखाया, क्योंकि उस काम को करने में इन 3 टूल्स का यूज होना था, ऑटोडेस्क इन्वेंटर, ऑटोडेस्क सीएफडी एंड ऑटोडेस्क रेविट। तो वो एक इंडस्ट्री प्रॉब्लम थी, उसमें हमारे पास डॉक्यूमेंटेशन की और कोएफिशिएंट्स की बिल्कुल वो थे ही नहीं, एग्जिस्ट ही नहीं करते। जो ओनली जो जिसने इनोवेशन का या किसी इन्वेंशन का जो जिसने बेड़ा उठाया वो तो गोरे लोग हैं, अब उनकी किताबों में भी वो चीज़ नहीं है, बट हम उसको यूज़ करते हैं, लेकिन हमारे पास उसकी कोई वो नहीं थी, प्रॉपर इंजीनियरिंग डॉक्यूमेंटेशन की हुई थी। तो इधर से फिर मुझे आइडिया, अगर कभी मुझे टाइम मिला तो मैं इसको डेवलप करूंगा, एंड लाइक सो मेनी अदर थिंग्स आई कीप ऑन डेवलपिंग लॉट ऑफ स्टफ फॉर माय ओन। लेकिन ये एक ऐसा काम था कि उसमें 1 साल से ज़्यादा चाहिए था, यानी कि अगर मैं मेरे जैसा आदमी काम करे तो फिर मैंने ये कोशिश की, और फिर मुझे वो अल्हम्दुलिल्लाह एक ग्रुप मिला 2016 यूटी लाहौर का, और उनको मैंने 3 से 4 आइडियाज दिए थे, उन्होंने अपने सुपरवाइजर से डिस्कस किए, और फिर उनको जो एक अप्रूव हुआ, फिर मैंने उनको कहा मैं तुम्हें ये सारा सिखाऊंगा, मैं जो मुश्किल पड़ती है यू कैन रीच मी एनी टाइम 24/7, एंड व्हेन आई से 24/7 आई मीन इट। लाइक मैंने उनको कहा था कि मुझे नोटिफिकेशन आती है, मैं उससे भी जाग जाता हूँ और मैं उस पर रिप्लाई करता हूँ। दिस इज, मैं ऐसा ही हूँ। ठीक है, उनको मैंने पूरा साल करवाया, मुझे उनके लिए 2 बार पाकिस्तान आना भी पड़ा, मैं 3-3 दिन उनके साथ गुजारे, उनको उनके साथ बैठ के सारी सारी रात कॉफ़ी शॉप में या कहीं पे भी हम बैठ जाते थे, इस्लामाबाद में एक दफ़ा, इस्लामाबाद में एक दफ़ा, लाहौर में। और मैंने उनको पूरा प्रोजेक्ट करवाया, और जिसकी वजह से दे गॉट इवन इंटरनेशनल वो रिकग्निशन बिकॉज ऑफ दैट, क्योंकि एक्चुअल इंडस्ट्री की। तो इस तरह के मेरे पास हर वक्त मेरे दिमाग में 20 से 50 आइडियाज हर वक्त रहते हैं। तो इफ़ एनीवन इज इंटरेस्टेड, मैं उनके साथ अपने आइडियाज शेयर भी करूँगा। इसका इनको ये फ़ायदा होगा कि इनको जो इंडस्ट्री में क्या चल रहा है, इंडस्ट्री में उसकी प्रॉब्लम क्या है, इंडस्ट्री में आने से पहले वो एक इंडस्ट्री की प्रॉब्लम सॉल्व कर चुके होंगे। ठीक है, नॉट जस्ट कि मैंने कुछ ऐसे ही कुछ नया बनाना है, कोई एल एन जी पर मोटरसाइकिल चला रहा है, कोई सुई गैस पर CD70 चला रहा है, भाई जो इंडस्ट्री में उसकी ज़रूरत नहीं है तो तुम क्यों कर रहे हो उसको, राइट? बिकॉज पाकिस्तान में एक ब्रिज नहीं है ना, प्रोफेशनल्स का और यूनिवर्सिटीज का ब्रिज नहीं है, देयर इज नो कम्युनिकेशन। इंजीनियर्स को भी नहीं पता मार्केट में क्या हो रहा है, मार्केट वालों को ये नहीं पता कि मार्केट वालों को तो वैसे ही कोई लगे, वो तो कहते हैं हम तो उस अजाब से बाहर आए हैं तो हमें क्यों वापस वहां पे तकलीफ दे रहे हो। ठीक है, तो ये है कि इस चीज़ की पाकिस्तान में बहुत ज़रूरत है, और मैं इस पर जो है आई एम ऑलवेज देयर। कोई भी है मेरे पास हर वक्त 20 आइडियाज तो मेरे दिमाग में हर वक्त घूम रहे होते हैं। तो फाइनल ईयर के स्टूडेंट्स को, और वो आइडियाज़ वो हैं जिनकी मार्केट में जो फील्ड में जिनकी ज़रूरत है, तो ये काम किया जा सकता है। इसमें हम जो फैकल्टी मेंबर्स हैं उनका भी ताउन अगर हमें मिल जाए, जो अपने फाइनल ईयर के स्टूडेंट्स को फ्लोट करें, सिखाने का यहाँ तक ताल्लुक है, ऑलवेज देयर, पूरा दिल जान से सिखाएंगे। उनको भी सिखाया था, मुझे सिर्फ एक ही ग्रुप मिला अभी तक, उसके बाद नहीं मिला। जी,
जी किसी का क्वेश्चन हो तो उसको कर लेते हैं, अदरवाइज फिर इसको क्लोज करते हैं। आई थिंक सर कोई क्वेश्चन नहीं है, और इंशाल्लाह
ठीक है।
आपसे राब्ते में रहेंगे। और पाकिस्तान HVACR सोसाइटी का यही मोटिव है कि इंडस्ट्री और एकेडेमिया के दरमियान जो गैप है उसको कम करने के लिए हम क्या कर सकते हैं। इसके लिए हमारा जो एक्सपो आ रहा है अप्रैल के फर्स्ट वीक में, उसमें हम ये स्टूडेंट्स को भी बताता चलूँ, फैकल्टी मेंबर्स को भी बताता चलूँ कि हम एक ट्रेनिंग डेडिकेटिकली इसके लिए प्लान कर रहे हैं और उसमें हम एक प्रोफेशनल ट्रेनर लेके आएंगे। तो आप में से जो भी इंटरेस्टेड हो इसमें, क्योंकि आज का सेशन रखवाया इसलिए था कि आपको बेसिक नॉलेज तो हो जाए, तो वो उसमें
इसमें ये है कि अगर इनको इनिशियली किसी चीज पर डालना है तो इनको पैरामेट्रिक मॉडलिंग का एक सेशन करवा दिया जाए। कोई भी एक चीज उठा के पैरामेट्रिकली बना के दी जाए। आई मीन एक है कि मैं कहूँ कि यार ये कप है, इसको 3D में बना दो, नो। वो तो कोई भी सिखा देगा आपको, तो कहीं से भी आप सीख जाएंगे, बट पैरामेट्रिक मॉडलिंग इज डिफरेंट थिंग, राइट। पैरामेट्रिक मॉडल का एक कोई भी चीज सिंपल सी सोची जाए जिसको हम पैरामेट्रिकली बिल्ड करें इन द 3D सॉफ्टवेयर, एंड देन अगर वो इस चीज को फील करें कि ओनली डूइंग इट वंस दे विल हैव 10, 50, even 100 models, different sizes, but just making it once on parametric, in a parametric way. तो अगर स्टूडेंट्स को ये आइडिया कैची लगता है तो we can have that if they are ready, if they are interested in it. If they are not interested, then obviously कोई यूज नहीं है।
जी सर, इनके साथ इंशाल्लाह हम एक फीडबैक फॉर्म शेयर करेंगे थ्रू फैकल्टी मेंबर्स, और ये जैसे इनका रिस्पांस आएगा तो वो हम उसमें कॉन्फ्रेंस से पहले भी ऐसी कोई ट्रेनिंग डिज़ाइन कर सकते हैं इनके लिए, और कॉन्फ्रेंस में भी उसको उस तरह। तो ये इंशाल्लाह आपसे रिक्वेस्ट है कि आपका जो यूट्यूब चैनल है उसका लिंक चैट में अगर डाल दें ताकि बच्चे उसको एक्सेस कर सकें।
चैट में तो से निकल जाएगा। मैं एक मिनट आपको दिखा देता हूँ। ये मेरा यूट्यूब चैनल है, रैबिटैसियन, राइट। तो ये अब मैं, दिस इज माय चैनल। अब तो इसकी चैट कहाँ से आती है, एक मिनट। हाँ,
तो जिस स्टूडेंट को इंटरेस्ट थोड़ा सा हुआ है वो इस चैनल को विजिट कर ले, और फीडबैक देने में भी आपको आसानी हो जाएगी। तो इंशाल्लाह फिर हम इसको आपके साथ राब्ते में रहेंगे।
अच्छा ये मैंने अभी ये देखे हैं बहुत ज़्यादा मैसेजेस, आई नेवर सी के ये कितने मैसेजेस आए हुए हैं। अब सॉरी, ये तो बहुत से लोग, ये क्यों क्या आ रही है ना।